Hey everyone, seeing I haven't been making YouTube videos for a while and I'm getting back to it now, I thought today's video I would redo the first video I made, the forging a Honesuki, except I'm going to do two parts together in this video. So, hope you enjoy, let's get to it. I'm forging this Honesuki out of this piece of 26C3 high carbon steel. This is a steel that I haven't used that much, but from what I have used, I really like it. It's very hardenable, it's a really nice edge, and I haven't had it in the 5mm size stock ever, but finally I was able to find some and get some. So I'm really excited to see how this comes out. I'm also planning something special, which I need this steel for, so you'll see that later. I'm going to turn on and set the kiln early here because I think the forging is not going to take that long and all of the thermal cycling I need to do before the kiln. So I got to get this heat up early. Make sure there's nothing in there. The last Honesuki I made for the YouTube video, it didn't end up really being a true Honesuki profile. There was too much belly to it, too much curve. So this time I'm doing my new Honesuki profile, which is a lot more traditional. This one's going to be pretty thick in the spine as well, but more of a distal taper forged into it. And just my forging and all of my experience has gone up quite a lot since the last YouTube video. So there'll be a lot of things changed from then. For the first heat there, I'm just trying to break the corners and start the taper. Now I'm going to forge out the preform of the blade, then switch to the tang, draw the tang out, and then switch back to the blade and forge in the bevels and the distal taper.
As I forge the tip of this blade, it's very important to keep forging the sides to make sure their overall thickness is the same for the preform. Unfortunately, I didn't get any audio for this part because I was experimenting with my new mic and I had it plugged in, but it turned itself off because it was idle for a while, I think. And so I was recording and I thought I would have audio, but I did not have audio. So that's just something I got to watch out for in the future. But here I'm still forging out the tip. It only takes a few heats to get here. I can move steel pretty fast with my hand hammer after all these years of forging. But just going along the edge, I'm forging all on the edge side here, pushing it down because of the profile of the Honesuki is very triangular. So I'm just making a big triangle with it and keeping the thickness even throughout the whole blade. I really like making Honesukis, but these aren't a regular knife that I keep stocked on my website. Just something I do every once in a while, or if someone wants one. But they're thicker on the spine, with a nice distal taper because you want that tip to still be very nimble to get around the fine parts. Because a Honesuki is a knife for poultry butchery and you want it to be really thick towards the back, still thin, very thin behind the edge to be very sharp, but you want enough support at the back to get through that heavy cartilage, but fine enough at the tip to do all your precise work. All the steels I use have different temperature forging ranges, so that's something to keep in mind when you're forging, is you need to know when to put your steel back into the forge and give it another heat. Because a lot of steels, when they get too cold, you'll start to crack them, and you really don't want that.
Now that my Honesuki preform is forged out, I'm going to flip it around in the tongs and hold the tip, and now it's time to forge out the tang.
When I forge out a tang, I'm putting a lot of pressure into that corner of the anvil. Here, I wish that corner was a little bit sharper so I could get it further in and forge the tang out more smoothly. But this anvil I'm using is quite rounded, so I'm just doing what I can.
Drop forged.
When I drop a blade when I'm forging it now, I always say drop forged after. I picked that up from my time that I spent with Martin Huber in his shop. That's something that he says a lot.
I really should invest in another pair of tongs to hold things better.
You can see the blade jump around there because I can't make full contact with the anvil in the corner because of how rounded the corner of the anvil is there. So for forging out tangs, nice to leave a sharp spot on the corner of your anvil. Not too sharp though, you don't want to chip out the side. There are quite a few different techniques for forging tangs. Some people just start with a bar and forge down on the corner of the anvil, or use a hot cut tool to make a notch, or just grind in a little line notch with an angle grinder. But here what I did is I cut out a small section. And I do this because then I can hold it with my tongs better, because I developed my whole forging process with only one pair of tongs, the ones I'm using here. And they can't hold a blade, they can't hold steel above 1 1/4 inches very nicely. So I cut it down to 1 1/4 inches out of my 1.5 inch stock so I can hold the tang side to forge the tip out, and then I turn it around and forge the tang out so I can hold it even better.
The tang is now roughly forged out. I'll go back and fine tune it and draw it out a little bit more later once the blade is all drawn out and forged to final geometry. Just because when you forge out the blade, sometimes things move around, so you have to correct the tang anyway to make sure everything's straight. So I just forge it out to long enough for me to hold it well, and so it's mostly forged out. Now time on to the final geometry forging and drawing out the blade.
A lot of time when I'm doing these YouTube videos, I feel like I forget how to speak. The speaking part is probably what's the most difficult for me, is getting comfortable talking to the camera and doing voiceovers that actually sound kind of natural. So that's something I have to work on, and I'll hopefully keep getting better at it as I make more YouTube videos. I'm planning right now to do 8 YouTube videos, 1 every week for the next 2 months-ish for the summer. And once I get there, I'll just see how things are going, see if it's starting to get a following or not, see if it's worth the time and effort I put into it. So, if you guys like the videos, please like the videos. Thank you.
Drop forged again.
As you forge the flats of the blade, everything gets thinner, which makes the material move less and less. Also, as the blade gets thinner, it cools a lot faster on the surface of the anvil. So these are all the things you want to be aware of as you're forging the flats, because you've got to really watch your temperature, and it really starts to move less and less as it gets thinner. So you got to hit really hard to make this stage go by faster. Don't hit too hard as it gets cold though, because it can crack your steel, so be careful. Although you have to hit very hard to move steel at the same rate once you're getting this thin, you do get a lot more of your energy back for your swing because there's less steel that's being moved. A lot more of that power is transferred into the anvil and back into your hammer. So if your swings are harder, but you get a lot of that energy back that goes all the way right up to the top of your swing. I started to get too much curve in the blade from forging out the bevels, so here I am just correcting, going back to that more triangular shape, trying to bring down the tip and the spot in front of the heel. It's also very important when you're forging to forge symmetrically. You want to keep even stresses in the blade on both sides. So switch over and hit each side of your blade. Don't do all your forging on one side. Otherwise, you could end up with a lot more warps and other stresses that can cause cracks. So you don't want that.
Now all the main forging is complete. I'm gonna take it to the grinder and give it a rough profile, then come back and do my planishing heats at a lower temperature in the forge, and then get it ready for heat treatment.
I like to give my blades a rough profile before I'm done forging so I can see the tapers more clearly and the thicknesses more clearly, see where I have material where I can draw out a little more length if I want to, or just places I can make more even, or if I want to make the edge thinner to reduce my grinding time once the blade is hard.
Now that I can see the thicknesses a lot more clearly, I see some spots I need to go back and refine at a lower temperature, planishing in the forge. Once I get everything done there and everything's at the dimensions that I want, I'll put my stamp on it and then start going through my thermocycling.
So right now these are not planishing strikes. I'm trying to forge out a little bit more length because after I profiled I measured it and I was a little bit short of my ideal length. It measured around 130 millimeter blade, but I wanted to get just a little bit more. Traditional Honesukis are around 150 millimeters. I'm okay with it being a little bit shorter than that. A nimble blade is pretty nice, and anything above 135 I think is pretty good Honesuki length. You could hear the alarm for the kiln going off at the end of the last heat there. Perfect timing because I'm just finishing up the forging, doing some planishing, getting everything final geometry and straightened. And yeah, so the kiln will be nice and ready for me as soon as I'm done the thermocycling. There I was also lowering the tip down again because I thought I had too much height at the tip. I want to make it more pointy, more triangular, so that's just what I was doing there, a little bit of light taps just to bring that tip down a little more. In this video, you guys are really getting to see a lot of the forging process. I recorded and included almost all heats. There was only one heat I didn't record because my phone started overheating, so it stopped recording partway through a couple of the clips I was taking through the end, near the end of forging, and then some of the thermocycling footage I was trying to get I did not get because my phone overheated. Now switching back to the tang, just to get the tang forged out, matched up to the rest of the blade, making sure everything's straight, and also just drawing it out a little bit more so I have a little more material going into my handle. In this stage, I also have to make sure everything is as straight as possible. I'm doing these heats at a lot lower temperature, bringing it down as I'm getting closer to finishing the planishing. So it kind of is a little bit of a normalization cycle too, but I'm going to do the proper cycles after this anyway, but just want to make sure that the steel remembers being straight.
Now that all the forging is done on this Honesuki, I'm going to take it through my normalizing and grain refinement cycles. Now, I'm going to do something special for this steel. I'm going to do a lot of extra grain refinement cycles at low temperatures, keep getting lower and lower, because I want to bring out the carbide banding in the steel so you can see a little bit of a watery pattern on the finished blade. It probably won't be super noticeable, but I want to see how much I can bring it out. So we'll see.
I think I did 4 or 5 cycles here. I don't remember exactly how many, but I did not get video footage of all of them because my phone overheated. So you just get to see, I think, 2 cycles that I got recorded, just the first normalizing and then my anneal cycle. But I did more than that, I swear. Also, you may have noticed from the thumbnail, you can't see much carbide banding, and there's a reason for that. I didn't really bring it out later, and you'll see why. Keep watching the video.
Now that the blade has been cooled in the vermiculite, I'm going to do some cold straightening just to make sure everything is lined up perfectly before I go to put it in the kiln for hardening. This blade is quite straight out of the forging, so I don't need to do a whole lot of correcting here. Making Honesukis is nice because the blade is so much thicker than what I usually do, so the chance of warping is a lot less than on my thin gyudos. And that looks good already.
Usually for my gyudos, I do an 8-second quench in the oil and then clamp between aluminum plates to help negate warping. But for this one, because of how thick it is and I wanted the steel to get a chance to fully harden, because 2063 is a shallow hardening steel, I wanted to let it fully cool in the oil. This is a specialty fast quenching oil called Hauto Quench K, and I also preheated the oil.
Quench seems successful so far, but now I'm just going to check with the file here. That sounds pretty hard, but there's a layer of decarb. Let's see if it, yeah, once it takes off the decarb, there's no biting in at all. Yeah, over the whole blade. Now I gotta throw it into the temper, and then it'll be on to the grinding.
For this one, I did 2 30-minute tempering cycles at 325 degrees Fahrenheit. Now, that's a lot shorter of a time than usually recommended for tempering cycles, but tempering is a factor of time and the temperature we reach, and the temperature is a lot more important. So I think as long as the blade is completely fully reached that temperature through the entire blade, then the temper should be fine as long as it holds that for at least a little bit, because temperature is more important than the time. And I could be wrong, but I believe most of these tempering recommendations are for more industrial applications, which are a lot bigger pieces of steel, so it takes a lot of time to make sure that piece fully reaches that proper temperature. But for a blade like this, it can reach the temperature in the oven very quickly. Here I wire wheeled the blade with a stainless steel wire wheel to give it, I believe, in the Japanese terms would be called a nishiji finish. But I think from my experimentation, that stainless steel kind of leaves a little bit of a coating on the scale, on the surface of the blade, which makes it a little bit more corrosion resistance on the upper part, which is nice. I like to round and polish the spines and choil of my blades on these 320 grit J-Flex belts, Works pretty well for me, and the belts last quite a while just doing this. I kind of prefer a little bit of a worn out belt to do this, as it leaves a little bit of a shinier finish on the blade, or on the spinach oil. I like to use a carbide file guide to grind out my tang and grind in the shoulders.
My phone is not far from dying now, so I've stopped talking to the camera as much because I really want to get this video done today, and I still have quite a few steps to go. I have the profile cut out and the shoulders cut in. I used the file guide to do that just now. So now I have to grind the bevels, polish everything, and make the handle. So hopefully I can do that before my phone dies.
When you're grinding your bevels, it's very important to keep them cool. So I'm dipping very, very frequently in my bucket of water. Make sure it's cold. That's also why I don't use gloves. I can feel the temperature of the steel heat up, so I can dunk it in the water when I feel that it's starting to get warm and make sure that it stays cool. Another thing that really helps is using fresh belts. It sucks to always have to buy belts, but fresh belts really cut material way more efficiently, save a lot of time, and you ruin less blades because it keeps the temperature down. I like to use VSM 60 grit belts for most of my bevel grinding. Once I pretty much go all the way down really, really thin on the 60 grit, and then go to my polishing belts. When you grind a knife with a distal taper, you have to account for that taper by lowering your angle as you grind towards the tip. So for my first rough grinding stage, I just keep the same angle and get the edge closer down. But then once I do that, I have to start lowering the angle towards the tip to make the shinogi line even across the blade. After my first stage, 60 grit grinding is complete and the blade is really almost finished grinding. The geometry is completely set, the edge is very thin. I do a vertical grinding on a 120 VSM belt. This helps with my finish and helps me line everything up to keep the edge nice and straight and really precisely fine-tune that geometry and get the edge thickness where I want it.
So unfortunately, while I was grinding, I noticed a bit of shadowy spots along the blade, and 2063 is a shallow hardening steel, which makes it really good for hamons, but that also means it's a low hardenability. So with a piece this thick, sometimes it doesn't harden through all the way, or you have spots that don't get fully hardened. And I found one on this blade. Once I saw that patchiness, I ran my file over, and I found this soft spot right here above the edge. So if I have it on the table and I'm running my file along, it doesn't dig in along any of the spot until I get right there. Then it starts to dig in, and it doesn't dig in right by the edge. So it'll perform okay for now, but as you sharpen it over time, you're gonna get up into that section, and I don't want a customer to have a knife that eventually is gonna stop performing as well. So this is just one that I'll keep. I can finish it because I really like this shape and the geometry on this. I think it's quite nice Honesuki, but I cannot sell this one. So it'll be finished for the YouTube video and I will keep it for myself, but I don't want a customer to have a knife with a soft spot too close to the edge there. My phone did end up dying, so I'm back in the shop now. Gonna finish this up. I'm gonna take out those scratches that I put in with the file there to check the hardness on this 240 grit belt here, and then I'll go over with my Scotch-Brite surface conditioning belt for the final finish on this, and then time to start the handle.
That soft spot is what I was alluding to earlier, and that's the reason I don't have my carbide banding showing. I did do a little test head, which also helped me find that soft spot, and it did show some of the carbide banding, so I could have brought it out, but it wouldn't really look very good with a too soft spot right near the edge on the blade, and it's really just not worth the time of me trying to go through the etching process and polishing process to bring that out nicely. when it's not going to show nicely and it's not a knife that I'm selling anyway. Here is me on the surface conditioning belt, just getting that nice fine finish. These things you got to be careful with. They will rip the blade out of your hand if you catch an edge sometimes, so be wary. And always go edge down on these.
For my handle wood, I buy it all separate and cut it up into my piece for my handle. So my bolster here is this piece of African blackwood, and then I have this block of walnut. So it'll go on the blade like that. So now what I have to do is to drill the holes and then file the slot to fit in the bolster, and then I'm going to drill a pilot hole and burn in the tang into this block.
Once I get all my center marks marked out for drilling the holes, I like to square up the block to the drill bit. Now, this is something that really helped my handle making and helped things get a lot more success rate, because sometimes things just aren't square, but if you square up your handle block to the drill bit, works a lot better. That's something I also learned from my time with Martin Huber over at his shop. Thanks, Martin. I drill a few small holes in the bolster block, and then I take a bigger drill bit and drill out the back of those. So when I'm filing it to shape, it takes a lot less time, and it just makes up the fit up a lot nicer and easier. I used to really not like this part of the process, and it used to take me a really long time with my old cheap files, but I got these really nice needle rasps, and these work really fast on the wood to file my bolster to shape, and I can get it to fit really nicely. Here it's a little bit too big, so I just take a little more material off the sides, and it fits nice. With my nicely fit up front bolster piece and the burnt wood block, once I glue those two pieces together, there's really not a lot of play in the handle at all, so I can comfortably shape the handle separate from the blade without bending the tang, because there's already not really any movement. Once it looks like everything matches up together pretty well, I'm going to take it and just sand the surfaces on my granite surface plate here to make sure everything is very flat, and it's going to glue together really well. And I also want to use a 220 grit so the glue can get a good chance to grab each side of the piece. Here I'm using a thick CA glue. I used to use thin, but it would harden too fast, and sometimes it wouldn't bond fully together. It would just harden on top of the one block and not make as nice of a bond. But this stuff takes a little bit longer to cure, so it really holds the piece together nicely. My handle making is definitely not my most precise part of my process. I do not use a whole lot of lines. I should really mark things more, but this is just fast and it works for me. And I've done it enough times now where it's not very often where I have something that's out of alignment. I can keep things pretty nicely just by eye and moving things. So for my handle process, once it's glued up, I just keep putting it on the blade and checking it, and then grinding away what is out of alignment. And I will first do the front, get everything looking good on the bolster side, and then grind towards the back, making sure everything's straight on the blade. And once everything's nice and square, I'll cut in the chamfers on the side, make it octagonal, and then from there move to my polishing belt and polish each side, each flat of the octagonal on the 400 grit aluminum oxide belt. And then once that's done, I'll break all of those little corners slightly, and then I'll chamfer the front and the back of the handle, and then slightly crown. That's what I'm doing here, is I'm slightly crowning just to make it a little bit round, the back of the handle. I think it's nice, and it also gets it polished too. There's the chamfer. I do the front chamfer a little bit differently than the back handle one because the African blackwood is harder than the walnut. So I get it on the flat of the belt, do it, make sure the sides are a little bit more than the tops and bottoms. And then I use this little gap between the wheel and the platen where it's soft, where I can just get it a little bit softer and rounder there. And once the handle's done, I clean up the tang to get it ready for the glue and make these little notches using the corner of the belt. This just gives the glue a little bit more to grab onto. Recently I've been using the hot glue to glue up my knives. Not on all of them. Some of them I use epoxy still in the applications where I want a really solid connection. But the hot glue is nice because it allows you to reheat it up and take the blade out of the handle in case you need to do maintenance on the blade. And it's something a lot of my customers have asked for, so I switched to it instead of using epoxy, which is very difficult and also dangerous to get off. The only way that I've found to get the epoxy on handles is by just holding the handle over the anvil and smashing it apart with my hammer. I haven't had any problems with the hot glue holding or it coming off later, but I'll keep that in mind and try to make sure it stays good, and I'll do some tests on this one because this one's mine. This is a beeswax based handle finish that I use to polish up the handles. You just put a coat on it and then wait a few minutes and it hardens up, and then you buff it with a nice cloth and it gets nice and shiny and it lasts on there for a long time. For the sharpening, I put the initial bevel on using this coarse DMT diamond stone. It's roughly 320 grit stone, but that's the only edge I'm going to put on this one because I want to keep a coarse edge on it, but I want to make it really nice. So the first thing you do is I'm going along one side and bringing out a burr. Now, I don't bring a burr across the entire blade on my first one because I'm putting the entire micro bevel on it and I don't want it to be completely lopsided. Now, the edge is very, very, very thin at this point, so it doesn't take that much to create that burr, but I just go till it's mostly on the first side, switch to the second side, go until it's completely on the second side, and then go back and forth, and then strop it. And that's how I do the initial edge on my knives. On the ones that I'm putting on my website, I will take them up to a 3000 grit edge, but this for a 320, it's not bad, and it can cut paper towel. Not the cleanest, but it can cut through the paper towel, which is pretty good for an edge that coarse.
Well, there you go. That was my remake of my making a Honesuki video. Hope you guys liked it. Ran into a few issues along the way, but I really like this design and size, and everything but the heat treatment went well. Just that little soft spot. Now, 26C3 is a steel I don't use a whole lot, so I'm gonna have to go through and refine my heat treating process for my new knives. But from the current knives I usually make, I'm using 5200 or Pops Pro Cut, which are steels that are a lot more hardenable, so I don't run into that issue with soft spots with those. So, always good to learn something from each knife you make. Thanks for watching the whole video. Please let me know in the comments what you'd like me to make for a future video. And yeah, please like and subscribe. Thanks everyone.